Hola, my name is Pamela. Welcome to my channel. Today I'm gonna talk about conductivity is the ability of an aqueous solution to conduct an electrical current. Pure distilled water does not conduct current in principle. But if mineral solids are dissolved in it, its conducting capacity increases. When the solids dissolve, they separate into positive and negative ions in equilibrium with the body. Ions capable of moving under the action of an electric field and also combining with other ions form new ions or different bodies that are no longer ionized. The conductivity of ions is a function of their concentration and their mobility in such a way that two voltage electrodes immersed in a liquid in which there is a salt in solution, for example Cl and A, will produce the following phenomena. The positive and A plus ions will migrate to the negatively charged electrode, which the negative Cl minus ions will reach the positive electrode. Upon reaching the electrodes, the ions acquire opposite charges and are neutralized. In this way, current is established through the solution and the external electrical circuit, which determines the effective area of the electrodes. The difference in potential and distance between electrodes and the temperature of the solution depend exclusively on the number and type of ions present in the solution. If the product is completely disassociated, it will be a direct measure of its concentration in the solution. The electrical conductivity is defined as the reciprocal of the resistance in ohms, measured between two opposite faces of a cube of side 1 cm immersed in the solution. The unit is the mho or Siemens, which is the reciprocal of the ohm, which is the conductance of the solution that, with a potential difference of 1 voltage between the faces of the electrodes, gives rise to the circulation of 1 ampere. Since this unit is too large, the micromho, which is 1 millionth of an mho, is often used in dilute solutions. In this table, we can see the conductivity values of various types of solutions. Measurement electrodes can be in contact with the solution or inductive or toroidal without direct contact with the solution. The toroidal sensor consists of two sealed parallel coils with an insulated probe. A coil is excited with AC, which induces a weak AC in the solution, which depends on its conductivity. In turn, this current induces a measurement signal in the other coil, which is the one that indicates the conductivity of the solution. In fact, the liquid acts as the core of a transformer. The first measurement system used was to place in the solution two parallel plates contacted by an alternating current Wheatstone bridge circuit. The circuit has the drawback that the gradual accumulation of dirt on the electrodes falsifies the measurement. The four-electrode measurement circuit compensates for this drawback by keeping the level of the alternating current constant. It uses two internal electrodes to capture the voltage drop in the solution and perform a high impedance AC voltage measurement, making the circuit less affected by the additional resistance caused by the coating of the measurement electrode surfaces. Four-electrode potentiometric circuit also compensates for the electrical effects of dirt built up on the electrodes. If the potential difference V0 between electrodes 2 and 3 is kept constant regardless of the resistance of the solution, the current IC will maintain a linear relationship with the conductivity of the solution, according to the expression that can be seen in the screen. Consequently, if the circuit maintains a constant potential difference V0 between two electrodes, regardless of the accumulation of solid deposits, the measurement will be proportional to IC, with the proportionality constant equal to the inverse of V0. V0 is compared with the reference voltage VR, and if there is a difference, it is cancelled through a self-balancing potentiometric circuit, indicating the value of IC at all times. The conductivity measurement requires compensation for the solution temperature in relation to the chosen standard temperature of 25 Celsius degrees. This compensation is usually automatic, consisting of a thermistor and a resistor Rn. It is worth mentioning that the addition of a microprocessor allows to obtain, by hardware or software, potentiometric conductivity circuits with different characteristics, since it has conductivity tables in memory. Their measurement accuracy is plus minus 0.5%, and the measurement range reaches a maximum of 0 to 150,000 micromoles. And well, this will be all for today's video. Don't forget to give me a like, subscribe, and share. I upload videos every Wednesday in Spanish and every Friday in English. Adiós!